Hello, this is Vivian Chen. In this video, I'm going to explain HSC 2018 Mathematics Extension to question number 12. Question A, it tells you that there is a solid with the base enclosed by the parabola, this one with the equation x equal to 1 minus y squared. Each cross-section of this solid perpendicular to the y-axis is an equilateral triangle, just like this one. And at different point of the base, the cross-section of this equilateral triangle should be different in size. So we have many different size equilateral triangles, and you can imagine all these triangles stack up to become a solid. The question asks you to find the volume of the solid. Now just try to imagine we try to cut this solid into many thin pieces, and each piece should be in the form of an equilateral triangular prism. If we can calculate the volume of each of this equilateral triangular prism and then sum up all the volume of these pieces, it will become the volume of this solid. Each piece of this triangular prism, the thickness, because we cut it horizontally, the thickness should be just a tiny little bit of y, and we call it delta y. And volume of prism should be equals to area of base times its thickness. And we now know that the thickness is delta y. And how about the area? We are talking about the area of a triangle. It should be 1 over 2 times the product of two sides length times side of the included angle. Since this is an equilateral triangle, each angle should be equal to power 3. And this is an equilateral triangle, which means the three sides are all equal in length. We know that one of the sides should be perpendicular to the y-axis. So the length of the side, it depends on the value of y you have here. Whichever value of y you have here, you input it into this function, it will give you a value of x. And the x value should be the length of this side. Let's say the value of y here is yi, and the area of this equilateral triangle should be equal to half. The corresponding value of x generated by yi should be 1 minus yi squared. This is the side length. And we need the product of two sides. Since the two sides should be in the same value, so it should be square. And then times sine pi over 3. And then multiply the area by the thickness delta y, it will become the volume of this triangular prism. What we are going to do next is to sum up the volume of all these pieces of triangular prisms all the way from the y value minus 1 to 1. This is talking about integration from minus 1 to 1, and we know that the value of sine pi over 3 should be equal to root 3 over 2. And this root 3 over 2 times this 1 over 2 become root 3 over 4. Therefore, we have root 3 over 4 times 1 minus y squared, the whole thing squared, and then delta y would become dy. This is the integration of a polynomial. We know how to do it. The root 3 over 4, we just take it out to multiply it after the integration. And the square, we expand it and then integrate it with respect to y, and the value should be 4 root 3 over 15. This is the volume of this solid. Question B, it gives you an equation of curve and asks you to find dy dx. Let's copy the equation of curve and do differentiation. Dx squared give you 2x plus differentiate xy, we need product rule. Keep x, you will have dy dx, and then plus keep y and differentiate of x dx, you get 1. So 1, you do not have to write it down. And then dy squared, you will get 2y dy dx. And constant, differentiate of a constant equals to 0. What to do next is simple. We just collect the dy dx, factorize it out, and transpose the rest without dy dx to the right hand side, and then divide the whole thing by x plus 2y, you will have dy dx equals to what required by the question. Question 2, asking for the point for dy dx equal to 0. This can be done by direct calculation. The dy dx is this one. It equals to 0 means the numerator equals to 0. So 2x plus y equal to 0, and we will have y equal to minus 2x. The equation tells you that the equation of the curve is this one. So let's copy it once. When y equals to minus 2x, let's just replace all the y by minus 2x. And we will get the value of x equal to plus minus 1. When the value of x equal to 1, according to the equation here, y equals minus 2. When the value of x equals to minus 1, the value of y equals to 2. So the points on this curve where dy dx equals to 0 are 1, minus 2, and minus 1, 2. Part C, asked to do this integration. The function for integration looks quite difficult, but you have to bear in mind that the degree of the numerator equals to 2. The degree of the denominator also equals to 2, and they are quite similar, except for this plus 5. Let's try to make this plus 5 out by plus 5 and minus 5 at the same time to the numerator. And then separate the numerator. Let's group them into two parts. The first three terms, let's group them into a group. And you can see that the numerator and the denominator, they are exactly the same, which makes them 1. And this minus 5 over the denominator. So now we know how to do integration of 1, but we don't know how to do this part. The complication goes to the denominator. Let's try to study this denominator. Separate the plus 5 into plus 1 and plus 4. Try to group these three terms together to make it x plus 1 whole square. And then you will have a square plus 4. We know a trigonometric identity, tangent square plus 1 equal to secant square. But the integration here is plus 4, not 1. So if we multiply 4 to the whole equation, you will get the identity of 4 tangent square theta plus 4 equal to 4 secant square theta. Let's just compare this identity with the denominator here. It seems that the x plus 1 should be equals to the 2 tangent theta. And we differentiate the whole equation, you will have dx equals to d2 tangent theta gives you 2 secant square theta d theta. And now we can do the substitution. The x minus 5, we just copy it, and then integration 1 over the x plus 1 become 2 tangent theta square plus 4. The dx should be replaced by 2 secant square theta d theta. The 1 and dx, they are in the relation of multiplication. Therefore, I can just skip the 1 and replace the dx with 2 secant square theta d theta. The denominator here, 2 tangent theta square plus 4, it gives you 4 tangent square theta plus 4, which sums up to become 4 secant square theta. And here we can see that the secant square theta, we can cancel between the numerator and the denominator. So after simplification, you have only now 1 over 2 left. And you can have this 1 over 2 multiplied to the function after the integration. Therefore, we only need to integrate 1 d theta, which gives you theta plus c. According to our substitution here, theta should be equals to arctangent x plus 1 over 2. So the answer of the integration should be equals to x minus 5 over 2 arctangent x plus 1 over 2 plus c. Part D. The question gives you the curve of y equal to fx, where fx is x over x minus 1. As you can see here, the x minus 1 is in the denominator, which makes it non-zero. Therefore, we should expect an asymptote at x equals to 1. And then you should also be aware that the numerator and the denominator, they are both degree 1 functions. So when x tends to infinity, we should expect the value of f(x) goes to 1. Therefore, we should also expect an asymptote at y equals to 1. After studying the function, let's take a look at the requirement of this question. The question asks you to draw the graphs for the following three functions, showing all the asymptotes and intercepts and everything. The first one, y equals to absolute value of f(x). Absolute value means all the positive stays unchanged, for just the negative values of y goes back to the positive. Therefore, we should expect all the positive stays unchanged, just cancel the negative part and then make a reflection about the x-axis. And this should be the answer for our question 1. Question 2 asks for the graph of y equal to fx squared. Square also makes the negative value of y positive, but this time it is not a direct reflection about the x-axis. For the value of y which is less than 1 but positive, y squared is less than y. Say for example, y equal to 1 over 2. 1 over 2 squared equals to 1 over 4, which is smaller than 1 over 2. Therefore, this part of the graph, after taking square, it goes below to the graph itself. 0 after square, it stays at 0, so they overlap each other. The negative part after being square, it goes to positive. The graph goes up from 0. This part of the graph, since the values of y are greater than 1, therefore after square, the graph would be located above the original graph. Let's take a look at the answer. The blue line is the graph of y equals to fx, which is provided by the question. The red curve here represents the graph of y equals to fx squared. As we have just mentioned, for the value of y which is between 0 and 1, it goes below the original graph. For the values of y which are negative, after square it goes up from 0. For the values of y which are greater than 1, after square, the graph is located above the original graph. Question 3 asks for the graph of y equal to x plus fx. This is the function of x plus fx. As we can see here, fx is a rational function with degree 1 polynomial in both its numerator and denominator. Let's try to rewrite this function by adding -1 and +1 to the numerator, and then consider the first two terms in the numerator, and you can see that the numerator and denominator are exactly the same, which makes it 1. We have successfully rewritten this function to a polynomial plus a rational polynomial, which the degree in the numerator is less than the degree in the denominator. In this form, we can now consider the function of y when the value of x goes to very large. As we can see here, when x gets large, this rational function will go to 0. And so the graph of y will only follow the straight line y equal to x plus 1, which is an asymptote of this graph. On the other hand, this function y equals to x plus fx, it is a rational function with denominator x minus 1, and the denominator cannot be equals to 0, and therefore the other asymptote of this graph is x equals to 1. This is the graph of y equals to x plus fx, with the asymptotes as we have mentioned, y equals to x plus 1, and the second asymptote should be the vertical line x equals to 1.